Okay? So, 1 is the start state. So I arrive at 1. Start state 1. It looks like rubber.
Yeah.
Yes, it's the second one. All right, so we arrive at 1, and so we've consumed no symbols. So where might we be? Well, we're clearly in state 1, but we can also be in state 2 because we can get there with an empty transition. So we've consumed no symbols. So we might be in state 2. State 2 goes nowhere on empty, and so that's where we might be upon consuming no symbols. Okay? Now we might consume an A. Well, if we're in state 1 and we consume an A, it goes to 2. 2 on empty goes nowhere. All right? So 2 on A goes to 4. 4 on empty goes to 1. 1 on empty goes to 2. And so we can be in that state name, 2 goes nowhere. Cool? Except I don't need to write the 2 again, I've already got 2 in there. And so this is then the new state name, or a state name that represents where we might end up consuming an A. Okay? Well, so consume a B.
That's also a final state because it contains 4.
Yeah, we'll do that later. But you're right, absolutely. And so we can do it now, I don't care. It's a final state because 4 is a final state. If any number is a final state, then that state becomes a final state. Okay, so B. 1 on B goes nowhere. 2 on B goes to 2 and 4. 2 on empty goes nowhere. 4 on empty goes to 1. 1 on empty goes to 2, but I've already got that. And so the order of these makes no difference. So that state and that state looks the same to me. We do these in pencil. All right, so we keep asking the same questions. State 2 on A goes to 4. 4 on empty goes to 1. 1 on empty goes to 2. 2 on empty doesn't. All right, so we got to there on from 2 on A. 4 on A goes nowhere. 1 on A goes to 2, which we already have. 4, 1, 2. 4, 1, 2. We do these in pencil. We ask the same question. 2 on B goes to 2 and 4. Four goes to 1 on empty. 1 goes to 2 on empty. All right, 4 on B goes to 3. 3 goes to 4 on empty. 4 goes to 1 on empty. I'd add 4 and 1 to the state name if it wasn't already there. Good? And so this has got another number, so this is a new state. And it'll also be a final state, since it's got a 4 in it. So now we ask the same questions. 2 on A goes where? 2 on A goes to 4. 4 on empty goes to 1. 1 on empty goes to 2. 2 on empty doesn't go anywhere. 4 on A goes nowhere. 1 on A goes to 2. 3 on A goes to 2. And so I get this state name. Yes? 412. 412. Two on B goes to 2 and 4. 4 goes to 1. 4 on B goes to 3. Arguably, we could quit at this point because 2, 4, 1, 3 is all of the state names, so we can't add any more state names, and we got them all. So we know that this is going to be the net result. So, do I have a deterministic finite automata? I've got to move from every state on each symbol. I've got no empty moves. Some of you made my grading of these quizzes easy. You drew an epsilon, an empty transition. You draw an empty transition for a deterministic finite automata, it's an automatic -8. That's supposed to have been funny. The question's only worth 3. Well, I'm probably not going to take off 8, at least not for a while. I might take off 8 on the first exam if you do the same thing again. What distinguishes the front end from the back end? The front end is language independent. The front end is target machine independent, where the back end is target machine dependent. Here, the work we do doesn't make any difference whether it's running on a Macintosh or an Intel or Linux or Mac OS, which is Linux, or Windows. We do the same work. When you took system software, the first thing you spent a fair amount of time on was learning the nature of the machine that it was going to run on. 3 bytes to a word, stuff like that. So the back end, which is system software, is machine dependent. Number 2, we've got to see, you want me to do this? You did pretty good on number 2. A digit, a pot full of digits. That might be all we see, because that digit plus question mark is 0 and 1 occurrences. E plus minus question mark, digit plus question mark, all of the rest of it is question mark. Question mark means 0 or 1 occurrences of. So this might be all we get. Only one of you didn't understand meta symbols. So when I grade these quizzes, so I told you on Thursday that I really enjoyed being here. And I do. I'm a little weary today, I'm not sure why. I'm worse today than I was Thursday. So I'm not enjoying it quite as much as I did Thursday, but I'm still enjoying it. I get to talk to you. But I don't particularly enjoy doing the paperwork, grading the quizzes, grading the exams. So I do them as quickly and arguably as efficiently as I can. And the way I think I can do that is grade one question at a time. So I have all the stack, so my eyes are looking only at the question. Grade, mark, grade, mark. And so I never look at anybody's name, and I just react to the questions. it allows me to do it quickly, and it allows me to do it anonymously, and so that's the way I do it. Now, Eric, I knew I was grading yours, right?
Yeah.
And Tom?
Yeah.
Yeah, so I knew I was grading yours. I can't help that, I mean, but, that's the way I do it. So, I can't remember why I was going by. Well, that's the way I grade quizzes and tests. So anyway, so we might see a dot digit. Well, so this might be all we get, so that's a final state. If we see a dot, then we must see a digit. And we can see 0 or 1 of those. Well, and we can see a pot full of digits. I can't put a circle on digit here because that would imply I could see 0 digits. I must see at least 1 digit. That's what the plus does. All right, so now we're in an E. Well, that might be all I get. Now we're in an E. So we might see an E. We may or may not see a plus or a minus. Now we can only see 1 plus or minus, so I can't see a bunch. So I can see 1 plus, or I can see 1 minus. And if I do, I must see a digit. And I can see a pot full of digits. Okay, so this can't be its final state because if I do get to here, I must see digits. This can't be a final state because if I do get to here, I must see digits. On the other hand, I may not see a plus or a minus. So I need an empty transition here to skip pluses or minuses. So I would argue that is a finite state machine that works. So that says I can recognize.
You're also missing an E going from the first accept state to the.
He kind of has it by putting the empty there. Instead of doing the empty there, he could have done, instead of the empty there, an E going from that final state to where he has an empty going to, would give the same result.
Doesn't mean skipping over the side, it means skipping over the point.
Period. So this machine is supposed to accept not only flood, yeah.
Right, but see, that's the same thing as putting it over there.
What he's trying to point out, what Steph's trying to point out is that this machine was supposed to accept both floating point numbers that have an E, but also just normal numbers that have an
Right,
E.
yeah.
So we need another epsilon transition before the period to take us to the E.
Right there.
There you go, yeah.
Is it just,
No, that's fine.
Floating works.
Oh, it's Epsilon. Oh, okay, Epsilon. Oh, yeah. I can't tell.
it ends on the reject state, not the accept state?
No, that's fine. That way it's an epsilon and an E.
Oh, okay,
So if
okay.
it's epsilon, it'll just skip and then E. It's the same thing.
Oh, it's the same thing?
Same logic. Yes, it's an epsilon. Here.
Oh, okay, got it.
You got it. Yeah, yeah. You're good.
Yeah,
We're good. We're Gucci now.
So that says I can see 23.4. That says I can see 23.4 E plus 5. I can see 23.4 E minus 5. I can see 23.4 E6. I can see 23 E7, which is why I needed the bottom epsilon you told me about. So I claim you ought to return int constant for this one And for all of these, you ought to return float constant. And I put all of these numbers as individual tests on project one.
So 23E7 is illegal,
Is legal,
and that's a float,
and that's a float.
but wouldn't that be an integer, because that's 23 to the power of 7? Or times
Well,
10
but-
to the 7.
But if we have E, it's exponential notation. And so we're calling that float.
Okay, so that should be a legal float in our.
That's a legal float.
Okay.
Now, you're right. I mean, technically, it's an integer. You can call it an integer if you want to.
Okay, but we should just have that in our project.
Yeah.
Okay.
And mine I call it a float, is that okay then?
You can call it a float, you can call it an integer.
The tricky part is if it was a positive, then it's more considered an integer, but if it's a negative exponential, then it's more really considered a float because, yeah, that's where it's tricky.
Yeah. That's pretty nasty. That's nastier than I realized it was nasty. You all hear what he said?
Yeah.
He said that if we have 23E plus 7, that is technically an integer. Matter, let's do it 23E2 because that's 23, yes. But if we have 23E minus 2, then that's, which has to be a float. So in your question, I can return this as an integer constant, but I got to return this as a floating point constant. I don't want it to be that nasty. You don't have to flip gears on the negative side.
All right.
And so just return them all as a float. Okay?
Sir, with that state machine, so 23E will be accepted.
I'm sorry?
Is 23E accepted in that state machine?
I still can't.
23E.
23E.
When I see the state machine,
The 23E won't be accepted. That's scientific.
I thought it was.
You what?
No, I didn't know that. I didn't see that it was an final state.
You good?
Yes.
I have no idea what you're doing.
I just didn't see that it was like that.
Hey, we're all in this together, right? Some of you had no idea how to do these questions, and I have no idea what the questions are. Well, we're all good. At least on this, that makes sense? No, it won't. Make sense. Good? I will put question 1 on exam 1. I will not put it on quiz next Thursday, but I will put it on exam 1. I'll probably change the numbers a little bit.
Question two?
Question 1. Question 0. I'm sorry, question 0. You're the one that makes me start at 0. So I gotta quit doing that. All my life I've been off by 1. Because C starts indexing at 0, right? You know that I've written programs to declare the array one size bigger so I could ignore the 0th position, so my logic wasn't screwed up, which is counterproductive. You know why it starts at 0, right? Because 0 is more efficient. It doesn't have to do any calculation to figure out where the number is.
Does that go back to get off a tangent, operating systems? Because we learned that on paging, they start at 0. Is that where that came from? No.
Yeah, that's all
Okay.
part of it.
Have you, how many programs have you written that offset by 1? How many have you written?
Oh, I don't know, maybe a few.
Oh, okay.
Most of the time I put up and figured it out, so it didn't necessarily.
Oh, okay.
But I have done that once or twice in my career of writing programs. You don't think that's a good idea? It isn't a good idea.
No, it's not.
Not a good idea.
Yeah.
Well, it's a waste of space. It's only a waste of one memory space though, one word, or unless it's an array of structures. Then it could be a bigger waste. So I promised you I would tell you what to do for submitting the project, yes? Nice hat, by the way. I like hats. My dad always wore a hat. He would never let anyone take a picture of him without a hat. Because he didn't want to be too bald. What? What?
You haven't done the answer for question 3. The quiz.
Oh. Anyone need question 3 on the quiz? Yeah, don't be shy. I mean, of course, if I say, yeah, I need question 3, then I admitted that I got it wrong, didn't know how to do it, right? So question 3, the goal, we're going to minimize the DFA. If we're going to minimize it, we want to shrink the number of states, right? It's got 6 states in it right now. We'd like to have something with fewer states. If we want fewer states, what must happen? 2 states must be accomplishing the same thing. So we got to simply figure out if any 2 states accomplish the same thing. Okay? Well, we know that states 0, 1, 2, 3, 4, and 5. Nah. 0, 1, 2, 3, 4. And state 5 do not accomplish the same thing. How do we know that? Well, these are not accepting states, and this is an accepting state. So not accepting states and accepting states got to be doing something different. Okay? Yes? All right, so we decide what's going on. We've got A and B. So 0 on A goes to 1, who is a group 1. This is group 2. Group 1. 0 on B goes to 3, group 1. 1 on A goes to 1, group 1. 1 on B goes to 2, group 1. 2 on A goes to 2, group 1. 2 on B goes to group 2. So 2 is guaranteed a different state than 0 or 1. 3 on A goes to 3, who is group 1. 3 on B goes to 4, who's group 1. 4 on A goes to 4, who is group 1. 4 on B goes to 5, who is group 2. So we see that we have some distinctions. So we see that 0 and 1 and 3 might very well be the same state. 2 and 4 might very well be the same state. And so now, and we've got 5 sitting out here all by itself. So this is a group 3, this is a group 2, this is a group 1. 0 on A goes to 1, who is a group 1. 0 on B goes to 3, who is a group 1. 1 on A goes to 1, who is a group 1. 1 on B goes to 2, who is a group 2. 3 on A goes to 3, who is a group 1. 3 on B is a 4, who is a group 2. 2 on A goes to 2, who is a group 2. 2 on B goes to 5, who is a group 3. 4 on A goes to 4, who is a group 2. 4 on B goes to 5, who is a group 3. So now we have 0, who is by itself, group 1, group 1. We have 1 and 3, who look to be together, since they're group 1, group 2. We have 2 and 4 that look to still be together. And we have 5 that's still by itself. So now we got to think about, so now we've got group 1, group 2, group 3, group 4. So now we only have to decide if these two are going to distinguish themselves. This one's all guaranteed by itself, that's guaranteed by itself. 1 on A goes to 1, who is a group 2. 1 on B goes to 2, who is a group 3. 3 on A goes to 3, who is a group 2. 3 goes to 4 on B, who is a group 3. 2 on A goes to 2, who is a group 3. 2 on B goes to group 4. 4 on A goes to group 3. 4 on B goes to group 4. So 2 and 4 did not distinguish themselves. So we have 0 who goes to on A. 0 on A goes to 1 and 3. 0 on B goes to 1 and 3. 1 on A goes to 1 and 3. There's a built-in check on this. 1 goes to 1. 3 better go to 1 or 3. It's got to go to the same state. You with me on the built-in check? 1 on B goes to 2. Goes to 2 and 4. 2 and 4 on A, B, 5, A, B. Good? Questions? Make sense?
And the 5 is an accept state, right?
So each of these questions are worth 3 points. 4 times 3 is 12. I like all my quizzes to be 12. That way when I type in the scores, I want to type in 1, 2. They're right next to each other. When I thought about this when I first started teaching. So I make the quizzes worth 10. Well, 8. Either they'd be good, but 12 is good because I can take off 1 or, well, maybe that all doesn't make any sense. If it's worth 12, I can take off half. That's what I'm trying to say. 6. Or I can take off a third, 4. But I don't actually do that because I usually got points per question. So. Anyway, told you I was tired today. Tired of today on Thursday. That's my excuse and I'm sticking with it. Questions on the quiz?
So
If I've done this in the past, if I give you this quiz on Thursday, will every one of you get 12 out of 12? Try it. Give it a shot. I might, maybe not the whole quiz, but I might give you one question. And if I give you one question identical from this quiz to Thursday's quiz,
that A goes back to the same to itself and A will send it back to a 1 or a 3? Is that what you're saying?
yeah. If I see an A, I'm still in that state.
Okay. So what was, and the check, and what does it check? That checks. Okay, I see what it's doing. I just don't understand why you called it that.
You see what it's doing, but what?
But I don't understand why you called it a check. Because
Called it a stack?
check.
Check.
Yeah. I
Check.
I don't remember saying any check today.
don't remember. Oh well.
I don't think I said any check.
Sir, so if there's two final states, then we group it into group two, right?
Yes, exactly. You can feel warm and fuzzy about this stuff. This is not a proof, but you can make yourself feel warm and fuzzy. Anyone want to feel warm and fuzzy? So the non-deterministic machine accepts this as an example. Does ours? Yep. The non-deterministic machine accepts for example. Does ours? And so at least with two examples, we feel warm and fuzzy about this because our deterministic machines, or our minimized machine, seems to accept the same strings as the initial machine did. Cool? Test yourself a little bit if you have time. All right, so I promised you how to do project 2. Project 1, I'm sorry. All right, so I'm on Osprey. And of course, that's where your project has to be. So I'm going to go to var public COP 4620 REE. This is our public directory. I'm going to go into examples. And so I'm going to do make directory project 1. And so I'm going into project 1. And so I've got nothing in there. So now I'm going to write my project. So I got to figure out how to do all this stuff. And so I decide, since I hate Java and I kind of like C, but I like Python better, I'm going to do my project in Python. And so I'm going to ask which Python. So user bin Python. And so in order to, this is just the way I write programs. User bin Python. Okay, so my P1 solution.py. So bang pound / user bin Python. Print, I think it's print in Python. Print, this is my good solution to project 1. You know, there are faculty who won't write programs in front of class because they're afraid of screwing up, but I'm not afraid of screwing up. I generally will screw up, but I'm not afraid of it. So I've got my project, so I got to do a CHMOP 777. Actually, I don't need that, I can do that. Now my project is executable, so I can type in my project 1 solution.py, and it ran. I'm so happy. So I've got the solution to project 1. Now I need a make file, and I don't know how to do this either. I think I write all : tab echo no make file needed. project in Python. I don't know if that works. Yeah, that worked. Because I typed in, see, when I have grading scripts that help me grade projects. My grading script types in make, so you need a make file no matter what. Okay? Now, if there's, I've got examples out here, I think. You're gonna love this. You didn't love it. We hate it. So I've got my project dot class colon my project dot Java tab Java C my project dot Java. So you do one of these two, you don't do them both. So for C++, we're going to do my program depends on my dot C++. Tab GCC all right, we're gonna do my dot O. I don't hardly know how to do. I know how to do C, but I don't know how to do C++ for sure. And so minus O, my program, my dot O. My dot O depends on my dot C++. GCC minus C, my dot O. So I claim that'll work for C++. On the other hand, I got C++, C out, I don't hardly know C++. This is good. No?
No, you need an extra
distraction, another arrow, 2 arrows.
Come on. All right. JCC my dot C plus plus. Expected conserve square feet of a token.
Well, it has to be inside of function. It just has to be in space.
What do I want? That fix it?
One library. Library is standard aisle street.
Aisle shoes.
Yeah, aisle street. There you go, that works too. You never end up, how it works.
I'm not supposed to have any trouble writing C.
Is it pound included?
Yeah, it's pound include for C++.
You take bracket two and do it straight to
All right, so this is good.
Yeah, actually, because the other person one that could make shit.
If you add line on C, you will also work
That's why there's
Yeah, this one's for numbers,
So now Makefile is a good Makefile for you.
So that's instead of to your, snap object. Big file.
So let's talk to me about C++.
So we don't need a make file for Python?
Well, I gave you the Python one to start with, which says you have to have it and have it say that you don't need it.
Okay.
Okay? Make sense?
So for the Java Makefile, do we need to list every project we got class before the .java? So you had to list my project.class, only my project.java, would that be every project.class, or every class.class, and then my project.java?
Yeah, and so you can do it. So I made a makefile.bat. So this is the one. So you can come in here and change this to an asterisk. And that way it'll compile everything. The MYPRJ must be your master main. But if you put the asterisk in, then it'll compile everything for Java and this will work.
Could you do it with the dot class too there then? Or is that, it have to be the main class, I guess?
I think you want to include this like it is right there. Okay? Okay, so now we need a documentation file. This is my project one documentation that explains briefly what I did. So you create an ASCII documentation file. All right, what else do I need? What?
P on top, TypeScript.
TypeScript. What else do I need before I need TypeScript? Is that all? Yeah, P1 script. So P1, so it's my program. So P1 script, I'm going to put in pound/bin/KSH. I want my P1 script to run in the core shell. You could have it run in Bash, doesn't make any difference. If you leave off the top line, it will run in your default shell. And so then I'm going to say,
We just call this P1.
I'm going to say my program Python $1. And so the $1 is the command line argument. For example, I'm going to put in, I'm doing shell programming now. It's not Java, it's not Python, it's shell programming. It's Bash, it's the core shell, it's shell programming. A print statement in shell programming is echo. So I'm going to print out echo. The first argument is $0, comma. The second argument is $1. And so then I got to change my program to make it, change my shell script to be executable. And if I type in P1 test file, it ran my program. Then it said the first argument is P1, the second argument is test file. And so this P1 right here was $0. This is $1. That's how you get the command line argument off the command line through the shell script into your program. Your program reads argv and argc if you're doing C, or it's what, I forget what it is in Java. Argsum, right?
Yeah.
And so the $1 will be the command line argument to your Java program. Make sense? All right, so now, I'm going to type in I'm going to type in script. And so it says script started, file is TypeScript. So then I'm gonna do an ls, and I'm gonna do char dot makefile my p1 solution dot py. What else do I need for my whole project? P1,
Makefile, TypeScript, documentation.
and I'm going to shell archive this into some file called output. All right, so it copied all of that. Then I'm gonna do make directory test, and I'm going to do change to test, and I'm going to copy my output file from the parent directory. I'm having a little trouble typing. To the current directory. And then I'm going to sh output. And then I'm going to type in make. And I'm going to edit my make file. I'm going to quit editing my make file. I'm going to edit my make file. Anyone confused yet? No? I'm going to delete my make file, and I'm going to type in all echo make file not needed. Then I'm going to type in make file not needed. Then I'm going to type in P1 test file, and it ran my P1 script correctly. And now I'm going to type in exit. Script done. Okay, you with me now? So now I got this file called TypeScript. TypeScript captured everything I just did. You know about less and more? Less is a pager that allows us to look into a file one page at a time, just to look at it. So if I look into the TypeScript file, see it anywhere. All right, if I type more and look into the TypeScript file, if I cat the TypeScript file and pipe it into more, maybe that'll work better. That didn't work any better.
I think it's just cat.
All right, if I edit the TypeScript file, that looks awful too. But it's all there anyway. And so what the TypeScript file, it captured all of the stuff I did. First thing I did was an ls. And then I sharded it at line 7. And then at line 13, I made the subdirectory, which is a test file, or is a test directory. And then at 15, so it captured everything I did. It just created a log of everything I did. You don't have to take a picture of it. It's in the public directory, and it'll stay there for you to view. You can take a picture of it if you want to. He's got 4 megabytes in his telephone, in his phone, so you can take a picture. So, everything is supposed to have a goal. My goal in having you create TypeScript is every term I get students who do their projects in Windows. They write Java programs and they use Eclipse or GGraph or whatever it is. They got a great program. It's got to run on Osprey. They upload it to Osprey, and they say, cool, Java is Java everywhere. Java isn't Java everywhere. They don't test their program on Osprey. I go to grade their project, it crashes flat out. Well, and so a whole bunch of work is down the drain because you all wrote a great project, it just didn't run on Osprey. So, what I'm forcing you to do, or at least encouraging you to do it with a reward of a few points, is upload your project, prove to me that you've tested it via the TypeScript file.
So what would be, if it does crash? If we run it, if we run it, say, in Eclipse or something, and then ran it on Osprey, and then it did crash, and it's working perfectly in Osprey, what about on Eclipse? What are usually the problems? Why would it not translate from one system to the other? Is it like classes? Is it the structure? Is it,
That's a good question. His question is, it ran in Eclipse, why won't it run on Osprey? And it isn't, well, it's a difference between Windows and Linux more than your machine and Osprey. So you're changing operating systems. And some of the things is, for example, in file names, Windows puts in a line feed and carriage return. Linux only puts in a line feed. If you write the make file or the P1 script and save it in Windows, it won't run in Linux. Scripts are cranky, they're picky. You've got to have just a carriage return. It's got to be a Linux file, not a Windows file. And so there's issues like that that can cause problems. So you got to test it. You with me? I apologize, my example didn't go as cleanly as I thought it might. On the other hand, I made it up as we went along. And I think there's value in me making it up because even though I've been doing this for 30, 40 years, things still don't always work right. And so if they don't work right for you, well, that's pretty normal. My wife gives me major accolades when I'm sitting in front of the computer. She says, you have infinite patience with a computer. I don't have much patience with lots of other stuff, but
My suggestion to the class is to write your P1 and your make file from scratch on Osprey, because it'll look right if you transfer it over, but it won't work, but you'll start from scratch and type it in there, and poof, it works.
yeah, and what he's saying is what I just said.
Right.
It's the result of the carriage return line feed.
So start from scratch. Only takes a minute to do, but don't save hours of headache.
And so the script. Well, and so we're not really done either. Because you've got to give me the TypeScript. And if we look in output, so See, all I've got is doc and make file in my solution in P1. So the char actually that I tested isn't really complete because it doesn't have the TypeScript in it. And I've been thinking about how to make that better, but I don't know how. And so I do char doc, make file, my P1 solution dot py, P1, and TypeScript, and I char all of that into output. And now I do turn in output to RE 4620_1. Maybe it's late and won't be accepted. It's due on Thursday.
You didn't show them to change the permissions yet.
I did too.
Did I miss that?
You did.
Okay.
If you look in my TypeScript, more TypeScript. That doesn't work. That's supposed to work better than that. This looks awful.
We're all getting F's in here.
They're all getting an F?
It's already leaving.
Yeah, exactly. That's
Is
what-
it 20 points a day?
So. $4620_1. 18. Thursday, what day? Today's the 30th?
30th.
30, 31, February 1st, February 2nd, February 3rd. So now I got a good output, and I do turn in output, RCE 620. Cannot write the destination. I'll fix that, I'll fix it all later. I'll fix it right away after class. Anyone got any idea what I've just been doing? No.
Submitting the file.
What?
Submitting the project.
They like the project? I'd like to know your name.
Abu Bakr.
Abu Bakr.
Abu Bakr.
Abu Bakr.
Abu Bakr.
Abu Bakr.
There you go.
He was saying something about change of permissions. I didn't hear that.
Yeah. I apologize. This is, you want Ron to take over?
There's a reason why I said we'll put off this part until Aidan gets back. It's confusing enough for me, let alone trying to explain it.
Well. So I need a make file, which you saw me do. Any questions on how to build a make file? Okay?
Yeah.
Yes?
Yeah. So,
So you've got to write, so you create a file, you put in your java.class, you put colon java.java on the first line. You tab it over, you do java C asterisk dot java on the second line. That's your make file.
okay, so that, and the java.class is the main file, or do you need to list all?
Yeah, you've got, in Java, you've got all that crap, right? Public, main, all that.
No.
And this has got to correspond to the name of the file.
Yeah, the main.
That's what this name has got to be.
Okay, so it's the main one, yeah, because it makes a whole bunch of .class files, so that one's the name of the
And
main.
so this will make all of the class files based on this one main file. So that's the make file.
Okay, so do you need to change the permissions on that?
No.
one, or-
No.
Okay,
So essentially, the make file is just the command that you would run if you were trying to run your Java file or compile your Java file on Oscar.
Yes. The make file is the command that you would enter at the command line if you were going to compile your Java program on the command line in Linux. Okay?
and it just has to be called make file, and then the make command just uses that?
Yes. This file must be called makefile. Make is a Linux utility that automatically looks for makefile. They're buddies. Okay? Good? We need a P1 script. It must be called P1. The P must be lowercase. In it, we write pound, bang, slash, bin, slash, BASH. We write in it Java, JA, $1. This JA is that JA, which is the JA.java you created for your project. All of those names must be consistent. Okay? So we create a file called just P1.
I can't see what you have. Is it like Java dot, what you have on it?
Is the command?
This is just Java space, JA space, $1.
Does it have to be that or the file name? Because it looks a bit like the
It
command.
is the file name. All of those names are consistent.
Okay, so it's Java, then the file name, then $1, which is kind of like the command to run a Java file.
Yes, it's the command to run a Java file.
So just to clarify, so the JA is the full name of the main, whatever is main in Java. Does that include the extension or does not include the extension?
With a script, it does not include the extension.
It doesn't usually include the extension it doesn't include the dot extension, the .java extension when you run it, when you're using the normal Java command.
So if I
It's,
edit JA.java and I write my Java program. So I got a file called JA.java. If I typed in Java C, ja.java, it creates ja.class. To execute this, I type in Java JA. Test file.
So you're just doing that, except, I see what you're doing, you're just doing that, except replacing the argument with a $1.
Yes.
Yeah.
This is, so 2/3 of you are going to write this in Java. 4 or 5 of you are going to write it in Python. 1 of you is going to write it in Ruby. 1's going to write it in JavaScript. 1's going to write it in C++. When I grade your projects, I don't want to have to figure out what you've written it in. So you all create this P1 script. Every one of you will call it P1. I will execute P1 with the test file. You'll code this P1 script, and so this line will do this, and your program will execute. If you write it in Ruby, then what do I have to have? I have to have Ruby program name test file. And so the P1 script then is going to look like Ruby program name $1. And I can run this by typing in P1 test file. You with me now? Kevin?
So the make file compiles it, and the P1 runs it.
Yes.
And that's basically an abstraction from the programming language, you could say. It makes it, I guess, sort of, it makes it so that you don't separate running it from the.
So there's lots of ways of putting a project together. The make file captures how to compile the whole project. The P1 captures how to execute this project. So yes, the make file is the compile plan. The P1 is the execution plan or technique or what have you. Okay?
We're all gonna use $1 as an argument. Correct. Okay.
That makes it,
Okay.
that makes it so your Java file can use args
This question.
when you're coding.
If you just create a P1
When
script,
you coded, you've been using arg0, right?
it's a
That way
plain
that
ASCII
ensures
file,
that you're getting that file's going to arg0.
but it must be executable in order to run your program. I did it, but it didn't show up. And so you have to do a chmod with, I like doing it with 777 P1. 777 is 111, 111, 111. That's permissions on the file. This is owner, group, world. This is execute, read, write, execute, read, write, execute, read, write. What I really only need is change mode 400. That would do it. That would make the file executable for me, who becomes the owner when you submit the project. I become the owner of the project. So the owner needs to be executable. 4 is 100000000. Execute for me, read and write, no. Group, the rest of the world, that's everybody else. Nobody else has access to this directory, so it doesn't make any difference. So you gotta make the project executable. Okay? You gotta make the script that executes your project executable. Your project will be executable anyway because of the Java command in the P1 script.
Sure. So if we do JavaScript, is a JavaScript program name then the second argument? Just basically.
Well, you've got to put in this P1 script. You've got to put the line in here that corresponds to how to execute the program. Now, my Python and my Ruby and my Java and my C are all accurate. I don't know how to run JavaScript off the top of my head. The last student who did JavaScript, I had to do a whole bunch of exotic things. And his P1 file was not just a simple line. It created directories and did all kinds of stuff.
I think it's the Node.js. I think for it to be possible to do it in the Osprey, you need the Node.js.
You can do JavaScript on Osprey. You got to jump through some hoops to do it. It isn't automatic. Good. And so then you need to do this change permission command. And then you've got to prove to me that you've tested your project via script. Then you got to turn it in. That's what I tried to demonstrate. I feel like trying to demonstrate it again.
So we're going to shard all files together.
You're going to shard all together. I feel like trying to demonstrate it again. I never give up. All right. So I'm going to try to demonstrate it again nice. So I've created my project. Okay. I'm going to go back here. Make directory my project. Okay. I'm in my project. And so I'm going to copy from project 1 my P1 solution.py. I'm going to copy make file. I'm going to copy my documentation file. I'm going to copy my P1 script. All right, so this I claim constitutes my complete project. Okay? And so I type in make, and so I got to fix the make file. I still got the wrong one. So my make file is echo no make file necessary Python. All right, so I do make. All right, and so I claim my project is good. P1 test, P1 works. So I claim my project is good now. Okay? So now I'm going to make a directory for test, a testing directory. Test copy everything from the parent directory to here. All right, so I've got 2 copies of exactly the same thing. So now I'm going to do script, and I'm going to type in make, and I'm going to type in P1 test file, and then, so I've proven that my project makes, it'll compile, and it'll run. So now I'm going to type in exit. So now I'm going to copy TypeScript to the parent directory. I'm going to move to the parent directory. And so here's my complete project. Now I'm going to char my project, my make file, my P1SOL, .py, my TypeScript, and I'm going to put it in output, and I'm going to turn in output to REE 4620_1. Oh yeah, I gotta fix that yet. But that's for me to fix.
For our TypeScript file, we're gonna need a test file to make it run. Do you want us to include that test file?
You can. It's good for you to include the test file. Once in a while, I got about 5 test files I run on this project. For project 2, I got 50. And so, once in a while, a student project will fail on every test file. It'll just crash immediately. So then I run it on your test file. If it crashes, then I say, okay, the project's no good. If it works on your test file, then I look at what's different in your test file and my test file to try to make an accurate grade. So you don't have to include a test file, but you can. Okay? So now I just did it. And that's really all you've got to do, is you're proving to me that it works. The second example was much simpler than the first one. That's all you've got to do. You with me? If I type in P1 and it won't execute, you'll see it. Then you put in the chmod, type in P1 again. When you're in the script, you can fix it. And then when you save it, well, you got to make sure that it's consistent in the parent directory. You with me? Because I didn't change the permissions in this example. But you do need to change permissions. Kevin?
Okay, so you say that we do need to change the permissions beforehand, but for the TypeScript, we just need to make use make and then P1 with the test files.
Mhm.
And that's all, and that's basically just demonstrate that it compiles and that it'll run.
Yep.
And that's all we need for TypeScript. And then for the char, we need the document, make file, the program source code, just the source code for it. Okay. The P1 file, the TypeScript, and the testing file, the test files. All right. And the TypeScript is just called TypeScript.
The default name for the TypeScript file, for the script file, is called TypeScript.
Yeah.
So script and TypeScript are buddies. Like make and makefile are buddies. Good now? Much clearer the second time, right? Questions? In the project spec, I give you points for all of these things. And so if you go See, it kind of tells you right here what you need. I give you 2 points for the P1 script, including making it executable. So if I type in P1 and it won't run, I'll fix it. I'll fix it for you so that I can grade your project, but I'm also going to penalize. 2 points for the makefile, 2 points for the TypeScript, 3 points for documentation, and then so then I run it on the 5 test files I have and look and see if you get right answers. So if you get right answers, you get 16 points. If you give me adequate documentation, you get 3 points. If you have a TypeScript file that makes sense, you get 2 points, so on.
What do you want us to include in documentation?
I want you to write, this is a lexical analyzer that scans C- input and creates tokens. You execute it, however you execute it. So the general philosophy on the documentation file. If you come back to this project 6 months or a year from now, for me it's 6 months, for you it might be a year. You won't remember what you did. I've got research projects. I published this paper on this research project. I don't remember how to run the program. I can't redo it. I write documentation files to myself so that a year later I can come back and say, this project does this, this is how you run it, this is the kind of output, that's what you do in your documentation file.
So like an overview of what the project does, as you were saying, and then you want like an overview of the classes, or do you want like an overview of, you know, just what it does, how you run it? Do you want like
Well, overview of how to run it, yeah. And
So like pictures, like snapshots of what we do to run it, to execute the program.
I'm sorry.
Snapshots, like takes pictures of everything we do, like the way we run the program.
you're saying like screenshots of the program,
Screenshots,
right?
yeah.
Yeah, no, don't put in a bunch of screenshots.
Not screenshots.
No. Just roughly a page. If you put it, I grade by volume on the documentation. If you put in 2 lines, I'm going to penalize. You put in 4 lines, I'll penalize, but not as much. You put in 10 lines, you'll be fine. That might very well be a poor way of doing things, but that's what I do just the same.
Can we put a funny joke in the documentation? Do you read it? Do you read your documentation?
I skim the documentation. I have had a student, they were writing, and all of a sudden there was a sentence in there, I bet you don't read any of this. And then more writing. And I know it's happened twice. It might have happened 10 times, but I caught it twice. And so I skim it I study every word or anything, but I look through the document, it looks reasonable. I don't like it, but I haven't penalized. And I probably shouldn't even say this. There are some students who copied the project spec and put it in their documentation. They copy this file. And they call that file the documentation. Well, it does describe what the project is to do, but it doesn't describe your project. And so if you want to be sure that you're going to get full points, edit this and make it specific to you. This is what it does in general, and this is how mine works. And that way you can write 10 lines of documentation instead of 40. A retired professor had an opportunity once to look at some of my student projects. Only 2 faculty in the last 30 years have taught this class. And the other one who's taught it's retired. But he had an opportunity to look at it. And he said, everything is great except you don't require enough documentation. That was his criticism. When you get jobs, your employers are typically upset with inadequate documentation. Well, okay, so that's on the one hand. On the other hand, you guys gotta work your tail off on these projects. And I don't want you to spend a bunch of time that isn't really productive. And by productive means functional execution of a program. I'll guarantee you that if you don't start Project 2 very nearly right away, as soon as we get done discussing Project 2, you're not going to get it done. Project 2, I did a piece of Project 2 last term for demonstration. I wrote 15 lines. It took me 3 days to get those 15 lines put together. And I knew what I was supposed to do. And I knew how to do it. It was still hard. And I did it in Python, which is easy. Still took me 3 days before it worked. And that was, you've got, what, 20 grammar rules? I picked out about 6 of them. And it took me 3 days to get those 6 grammar rules to work. So, and Project 2 is the core. By that I mean Projects 3 and 4 rely on Projects 2's correct execution. Project 3 can be fairly crappy and you'll get away. Project 4 can be moderately crappy and you'll be okay. Project 2 has got to be good.
Sir, do you suggest us to do Project 2 before you grade the Project 1? Or
Project 2 uses Project 1's output as input.
Or should we wait for you to grade Project 1 first before we do Project 2?
Project 1's due Thursday. You've got to do that before Project 2.
I know. I mean, I think, should we do Project 2 after you grade Project 1, or can we do it?
I'll grade Project 2 or I'll grade Project 1 on Sunday. So you'll get it back right away.
Thank you.
Okay.